Hi guys, welcome to the latest video on arrays. Today we're going to look at how we use arrays, why we use arrays, how we assign values to an array, how we access values from an array, how we can then update them, and also looking at examples of one-dimensional and two-dimensional arrays. What you can see in front of you is a little diagram, a representation of a array. This is a one-dimensional array, and we need to learn a few terms. So if you can see here, there are some numbers going from 0 to 5. That is called the index. So if I say what's at index 3, you will quite clearly see that it is 33. What's at index 1? It's 62, and this is something that you need to get your head around, is that the index, unless said otherwise, will start at 0. So what is in the first position? 45 at place 0, i.e. they don't start at 1, they start at 0. And there are 6 of values here, going from 0 to 5. And what arrays allow us to do is allow us to store values of the same data type. You can see here all of these are whole numbers and therefore are integers. You can't mix and match with an array, so you either have strings, or you have integers, or you have real numbers, double or booleans, etc. And in this case, in my example, these are test scores, so these are between 1 and 100. The first score was at 45, and then 62 and 92 and 33 otherwise. Just want you to take a moment to realize that if I didn't have an array, the only way to store all these different variables would be to have 6 separate variables and storing the values like that. Okay, let's look at how we actually make use of an array, what the pseudocode is for it. It has to have a name, and in this case, the name of my array is scores. I'm going to use the command to output a value, and let's say I want to output the value here, 33. Here's how I'd reference it. I reference it by the name of the array, so scores. I then draw square brackets, and inside those square brackets, I put down the actual number in the index. And so because I'm looking for 33, you can see it's at index position 3. That will now output 33. The other way around, let's say I want to update a score. Say if I update a scores, let's say I want to update 88. This time the person retook the test and did a little bit better and got 92. So I can see I want to update the value here. First time around they got 88. It's held at index 4, so if I want to change that, I need to do square brackets, do the index is 4, and then draw the arrow to update, and the new value, which is, what did I say? I think I said 92. And what that will do is that will place 92 into this position here. This is how you access an element. This is how you update the value in an array. Okay, let's work together on a bit of an example. So this, we're doing a bit of we together. First of all, let's talk through what's going on. Here's the representation of the array you saw before. This line, this is saying how you declare an array with some values. Square brackets, these are all the values separated by commas into the new variable called test scores. Then it's going to ask the question, please pick the number of the test you want to view. Test 1, test 2, test 3. Remember, index 0, index 1, but if you were talking to a regular person, they'd say, that's test number 1, that's test number 2, that's test number 3. You then get the person to input it, and that's sort of in score number. So they might say, I want to see test number 3. Score number would store 3. And then output test scores, score number minus 1. Why did we take that 1 off? Well, because we're saying if they want to see position 3, then if they want to see the third test would actually be here. But as you can see, that's actually at index place 2. So if I put in 3, 3 take away 1 is 2, and it would output 92. If I wanted to see the final one, so that's number 6. 6 will be stored in here. 6 take away 1 will give you a 5. Now, let's build on this a little bit. Ask the end user which score they want to update, then prompt the user to input the score. So let's do the bit of update. So first of all, we want to ask the question output, and we do the question. And so we'll ask the question, which score do you want to change? We're then going to need a position. We then, so we've got a user input going into select. So select will be the individual one, whether it's test score 1, 2, 3, 4. Remember, it's still index 0, 1, 2, 3. Next thing we need to do is ask the question about what the new score is. Since we've now asked what the score, we'll just need to have another variable to record that new score. Okay, now we have the information we need. We know the position in the array where we want to store it, wherever that is. We know what the new score is. Just take a moment, pause, and think, how are you going to write the syntax to update the array with the new score? Pause now. Okay. So to be able to change the score, you're going to want to get the name of the array. So that's test scores. Then you draw the square brackets to indicate the position. The position is indicated by this variable here called select. And so we'd write select in the square brackets. Remember, if they said they wanted to update test number 2, so let's say that's the second test, the actual position is index 1. So we'll have to take 1 off to get there. Again, if they wanted to go and do test 4, which will be this test, they have to take 1 off to get index 3. So select, and then we'll have to take minus 1 off it in square brackets. Okay, so that gets us the position where we want to put it. But now we need to actually update it with the value. So to update, we indicate with the arrow, and we're going to update it with the new score. So then we can update it with that one there. Okay. Bit of a change this time around. What we've got here is we've got a bit of pre-written pseudocode and a trace table with accidentally a bit put in, so don't worry about that though. What I'm going to do is I'm going to start the trace table off, and then you are going to keep working on the trace table. We'll pause, we'll do it line by line. You give it a try first though. So all you want to do is work your way down the variables and update in the trace table here. We're going to use the same array of scores. The first thing you're seeing is A is 33, so 33 will go in there. Then you can see straight underneath it, it says false. B is false. C is set to, and this is a new thing you've not seen so far, len. Len is just short for length. So it's the length of the test score. You might be tempted to say 5 because it ends in a 5, but length would just say the number of elements. 1, 2, 3, 4, 5, 6. And in fact, it's something worth knowing. If you want to access the last element in an array, just get the length, which in this case would be 6, take away 1, gets you to 5. If there were 10 items, you go length of that, take away 1, because the last index would be at 9. So anyway, C in this case is 6. D was set to 0. Then let's look at this loop. It says while B is not equal to true, false is not equal to true, so that's right, and D is less than C. Well, D is 0, C is 6. Is 0 less than 6? Yes, so that would return true. So that's saying true and true, so the while loop continues. Then it says here, it says if A is if A is the same as what's in test scores D, well, D is 0. Test scores at 0 is 45. Is A the same as 45? Well, A is 35. Is that the same as A is 33 rather? Is that the same as 45? No, it's not. So we can say there's been no change there, but let's write that in. So the test score was 45. 33 is not the same as 45. So this if does not happen. Then we go here. D is now D plus 1. So D was 0, D plus 1, and now D is 1. Okay. Now recognize A is not going to update because we're inside the while loop. B could change if we're in here, but it hasn't happened yet. What we want to do now is come back in here and say, is B not equal to true? Well, B is still false, so it isn't equal to true. And D is less than C. So D is less than C. Is 1 less than 6? Yes, it is. So that's still true. So the loop continues. Test score is now at position D. Because D is now 1, the test score at position index 1 is 62. There we go. Here's what I want you to do. I want you to pause now and see if you can see how the rest of this is filled out. Okay, I'm going to start walking through the rest. We were down here. We're still in the while loop. D is D plus 1. So D is now 2. Is D less than C? Is 2 less than 6? Yes. So true. Test scores at position, because we're testing this if statement, test scores at position D. D is 2, so test score is 92. Okay. Is 92 equal to 33? It is not. So we're going down to the bottom here. D is D plus 1. And so this time D is 3. We come back to the beginning of the loop. B is still false, so not equal to true. D is D less than C. Well, since D is 3 and C is 6, it's still true. So the loop continues. And then D has been, since D is now 3, we can look at position 3, and 3 is test scores D. If test scores if D is 3, then we have to write 33. Now, if you look, if A is 33, is the same as test scores D, which is 33. So this if is now triggering, then B becomes true. So now we can say B is true. Okay. Worth also pointing out that also D becomes 4, because that is going to happen. The while loop continues here. It says if B is not equal to true, or B is true, so that's going to be false. And since it's an and, if it's false and true, is 4 is less than 6, it's still going to be false. So the while loop ends, then it outputs a D. And so it sort of looks like it's outputting that we've kind of found the value 33 at place 4. Is that correct? You can see that's wrong, because actually D is at place 3. In fact, what we've just demonstrated is a linear search. It's going through each item at a time until it finds the item, and then it's outputting the position, except that's wrong. Think for a second what you could do to change here to help fix the problem. That's right. If you put -1 there, it will help you solve the problem. Okay, guys, I'm leaving this over to you now. This is a exam question from a previous year. Write it in your books. Give it a try, including this algorithm here where it's talking about create an array called cupcakes, containing a list of cupcakes. So you know how to do that, how to create a new array, one-dimensional. Replace the cherry cupcake with a raspberry one. You know how to update, and then write an algorithm that asks the user to input the flavor they want. So you know how to ask a question and input. Searches the cupcake array for that flavor. We've just done something very similar to that. So you can do a loop. and then outputs a simple message depending if that flavor is available. Because of course, it might be that you're searching for something that's not in the list. Give it a try. Okay, we're moving on to the next concept now. Before we had one-dimensional arrays, and you can imagine that's just like a list. We're now using two-dimensional arrays. Now, this is just looks like a table or maybe a spreadsheet, and effectively that is what it is. You just have two values. You've got the number of columns, the number of rows. Down here, you can see some attempts at referencing it. It says output scores 2 and 3. And I guess the only thing you don't know right now is, does 2 refer to the column or to the row? Well, the convention for this is that the 2 refers to the row, so it refers to that one there, and 3 will refer to the column. So the first refers to the row, the second the column, and so you can see that that will be this value here, 73. Whoops, 73. How about this with this 96 thing here? Well, it says scores at 0 to, let's remember again, so 0 will mean it's going to go here, 2 means it's going to reference that one, so it's going to update this to 96. Finally, output scores 1 and 3. 1, that first value here, it's going to reference this, the row. 3 is going to reference this, the column, and so it's going to give you that output. Apart from that, the arrays work the same way, must have one data type only. The only difference is that it's a table. And what you can imagine is that this time we've got 4 scores that tests that are taken, but each of this is a separate student. You know, this is student 1, student 2, student 3. I'm sure other names are available. Okay, let's do a bit of we working together. This, by the way, is how you declare a two-dimensional array. That's the first row, you can see there, comma, in square brackets, the second row there, comma, the last row, square brackets. Witness how each of these individual ones here basically are single arrays, are one-dimensional arrays. Really, it's like sticking 3 one-dimensional arrays together. Okay. Here's what we're trying to do. It says each line of the array represents a student. Student 1, student 2, student 3. Please calculate the average test score. So now we want to go through all of these arrays, generating an average test score. No problem. Let's do it together. Let's first of all think what we need to hold. Well, we're going to need a total, because to get an average, we need a running total, and in the end, divide it by the total number of values. So total, start it at 0. Now, to do this, if it was just one array, we'd use a single for loop, go once, add that, add that, add that, add that, for loop ends, get out of it. But because we've got these 3 rows, we are going to use what's called nesting. We do one for loop. So we do one for loop here. That's going to go, let's start I at position 0. And 2, because there's 4 values here, to 3. So 0 to 3. In fact, let's do the other way around, 0 to 2. So we're going to go all the rows. So it's going to start at row 0 here. Then what we want to do is write another for loop nested inside, indented. So the first one's basically going to go look at row 1, then look at row 2, then look at row 3, or I should say 0, 1, and 2. But now we're saying once it's on 0, we need to look at this position, this position, this position, this position. Come back up here. I'll draw it for you in a second. Let's see what it looks like. I don't want to use I because I've just used it, so I'll use J from position 0 to 3. So that's the one that's going to creep along this way. What we're going to do is we're going to say total is going to be assigned total to keep a running total going on, plus the name of the array, which is test scores, square bracket, I, because that is going to be the one that moves from 0 to 1 to 2. So that's 0, 1 to 2 there. And remember, the row comes first. And then the other square bracket will do, I've done a bit of bad here because I was going to be greens for all my variables. There we go, I. And then the second bracket, we will put in J. Okay, and then we're going to close these two. Okay, guys, go along with me. This is actually not as tricky as it may seem. We're going to keep a track of how these loops work. So in the first loop here, we say I starts at 0. We've dropped down, and now we're initializing J at 0. Well, where's that on here? Well, that is that. I0, J0, that position, 0, 0. So 45 gets added to total. We come to the end of the for loop, comes back here, and J then becomes 1. We don't change I because we're still stuck in this loop here. So I is 0, J is 1. That's here, 62. J becomes, we're still in here, J becomes 2. It's 92. Remember, I is still 0 because we're still stuck in this loop here. And then J becomes 3, and that gets us that position there. When J becomes 3, this for loop ends, and we come back to the original loop. I is not 0 anymore and moves up to 1. So now I is 1. J gets put back to 0. So 1, 0, 1, 1, 1, 2, 1, 3. Comes back again to 2. Get that back to 0. 2, 0, 2, 1, 2, 2, 2, 3. 2 is finished. And then we are not quite done, because what we need to then is output the average. And the average is going to be total divided by the number of elements, which is 12. And that will give you the answer. Okay, over to you this time. We take the original bit of code, this two-dimensional array, and you've got a couple of challenges. First challenge. Each line of the array represents a student. Calculate the average test score for each student. So we want to find the average for this line here, the average for this student here, and this student here. Or if it helps, that student, what's the average score? That student, what's the average score? That student, what's the average score? If you successfully get that done, well done. Next challenge is this. Calculate the overall highest grade. So that's for everybody. Who's got the highest grade overall? And who's got the lowest grade out of all of these? And which student got it? So actually, you can see here that the highest score is here. So it should be that you say the first student got it, or where that row is 0. And the lowest score, as you can see, is here. And it's got by the second score. Right. Take it easy. Feel free to go back to see how we wrote the last one together and have a go at trying to solve this one in your books.